To all my viewers, welcome into our today's session, whereby we are still going to discuss about Laplace transform of our function here f of t using the first principle. When it comes to the first principle, the first thing that we need to understand is that how to apply the first principle formula. And by the first principle formula, we know that the Laplace transform of our function f of t is equals to integration with respect to our limits, exponential negative st we multiply by our function f of t, and our integration is with respect to d. After writing down the first principle formula, we are going to apply this first principle formula in solving our equation here, which is equals to a function f of t, to mean that the Laplace transform now of our function f of t, which is equals to exponential 4t sine 5t is equals to integration with respect to our limits, exponential negative st. Our function f of t is equals to exponential 4t we multiply by sine 5t, and our integration is with respect to time dt. From this point we can come and open the bracket, and by opening the bracket we are going to have the Laplace transform of our function f of t is going to be equals to an integral with respect to our limits, exponential negative st we multiply by exponential 4t, hence and lastly we are going to multiply by sine 5t. Our integration here is with respect to dt. At this point now, we need to find a way by which we can convert sine 5t into an exponential. And for us to do that, we need to consider, we need now to bring in consideration into the complex numbers formula, whereby we understand that exponential theta j is equals to cos theta we add to j sine theta. Our angle here of theta is equals to 5t, to mean that the exponential 5t j is going to be equals to, here we are going to have cos 5t we add to j sine 5t. From whatever we are having here, we can end up with two equations, whereby we can come and say the first one will be exponential 5tj is equals to cos 5t, and exponential 5tj is equals to j sine 5t. Whereby in the complex number, we understand that cos is located on the real side, j sine 5t is located on the imaginary side. Hence, we can come and introduce here an r to stand for the real side, and here an I to stand for the imaginary side. After understanding this point, now we can continue, because when we come here at this point, we understand that sine 5t is equals to I exponential 5tj, to mean that already we've converted sine 5t into an exponential, And let us now proceed with our working. When we are proceeding with our working, we understand that the Laplace transform of our function f of t is equals to integration with respect to our limits, whereby we have from infinity up to 0 as our lower class limit, exponential negative st, we multiply by exponential 40, and lastly we are going to multiply by I exponential 5tj, and our integration was with respect to time. At this point now, we are going to factor out I because it is not a term of dt, and the remaining exponential, we are going to reduce them by using the laws of indices, because here we have an exponential, and an exponential. And by using the laws of indices, we understand that when the bases are equal, we take one of the bases, we add the powers since it is a multiplication. And by doing that, we are going to have the Laplace transform of our function f of t is going to be equals to an integral with respect to our limits, exponential negative st, we come and add to, sorry, here we are supposed to be factoring out I, we add to 4t, we add to 5jt, and our integration is with respect to dt. To mean that we can come and rewrite everything, the Laplace transform of our function f of t is going to be equals to I, an integral with respect to our limits, exponential negative s, we add to 4, we add to 5j, and our common term of t. Up to this point now, we can do our integration, because we know that an integral of, let's say, 4x is always equals to, an integral of this one is equals to exponential 4x all over 4. To mean that the coefficient of x is what we come and write down there. When we come here, it is quite very easy to do an integration of an exponential. When we come here, we are now going to have the Laplace transform of our function f of t is going to be equals to I, into, because we are going to carry out our integration. Here we are going to have exponential negative s, we add to 4, we add to 5j t, and our integration is going to be equals to, we are going to treat this one as 4. Hence, we are going to have s, we add to 4, we add to 5j. And our integration is with respect to our limits. At this point now, we are going to factor out the denominator. After factoring out the denominator, we do away with our limits. And this is what we are going to have. The Laplace transform of our function f of t is going to be equals to I all over negative s, we add to 4, we add to 5j into exponential negative s, we add to 4, we add to 5j, we multiply by our function f of t. Let us now do away with the class limits. And when we do away with the class limits, just like in other videos that I've done, we are going to have now the Laplace transform of our function f of t is going to be equals to I all over negative s we add to 4, we add to 5j into exponential negative s we add to 4, we add to 5j. We come and insert our upper class limit to the term of t. We subtract from exponential negative s, we add to 4, we add to 5j, and we come and insert our lower class limit. At this point now, we understand that when an exponential has been raised to a power of an infinity, is going to be a 0. And when an exponential has been raised to a power of 0, because whatever we are having here, we multiply by 0 is going to be a 0. When an exponential is raised to a power of 0, we are going to have 1. Let us now simplify whatever we are having here, whereby we say that the Laplace transform of our function f of t is going to be equals to I all over negative s, we add to 4, we add to 5j, everything is equals to, here we say that we are going to have 0, we subtract from 1. From this point now, we understand that the Laplace transform of our function f of t is equals to, with respect to our limits, this negative is going to affect whatever we are having here on the denominator, and we are going to have now a positive of s. We subtract from 4, we subtract from 5j. Now we are done with the negatives there. At this point now, the only thing that we are required to do is to separate the real functions and the imaginary function. How do we go about separation of the real function and the imaginary function? We understand that we need to take our rationalization at this point. When it comes to the rationalization, we understand that we must multiply whatever we are having on the denominator by its conjugate. And this is what I mean multiplying the denominator here by its conjugate. We are going to have now s we subtract from 4. This one is going to be on the real, are going to be the real functions. Why? Because they do not have our term of j. And here we are going to add to our imaginary function, which has got a term of j. And this is now what we are going to have as our conjugate. We are going to take the conjugate of the whatever we are having on the numerator, we multiply by s, we subtract from 4 as our conjugate. Here we had to 5j. On the numerator, we are going to have the Laplace transform of our function f of t is going to be equals to I into s, we subtract from 4, we add to 5j all over. On the denominator here, this is how we are going to simplify the denominator with the easiest way possible. When we are having a, for example, we add to b, we come and multiply by a, we subtract from b. These two, for us to open the bracket, we are going to take this one, we multiply by this, of which we are going to have a squared, a multiplied by this one, we are going to have ab. This one multiplied by this, we are going to have a positive of ab. This one multiplied by this, we are going to have a negative of b. of b squared. To mean that these two are going to cancel out because this one is a negative, this one is a positive. These two are going to cancel out, and we are going to have our answer as a squared. We subtract from b squared. Let us now come here. We understand that this is our term of a, this is b, negative. This is our term of a, this one is a positive of b. To mean that here in our working at this point, we agree that we are going to have a squared, we subtract from b squared. What is our a squared? Our a squared is going to be s, we subtract from 4, everything squared. We come to a subtraction of b squared. What is our term of b? Our b is equals to 5j, but everything is going to be squared. Once you've understood how to go about this, now we can simplify whatever we are having on the denominator and have our real functions and the imaginary function separately. Now let us continue. The Laplace transform of our function f of t is going to be equals to I into s. We subtract from 4, we add to 5j. Everything is going to be all over. Here we are going to have s, we subtract from 4, everything squared. Here we are going to have a subtraction of 25 because we are going to square 25, and here we are going to have j squared. At this point, the only thing that we are required to carry out is to do away with the j squared. We understand from the complex numbers, we understand that j squared is equals to a negative of 1, to mean that when we come and replace a negative of 1 at this point, because j squared is equals to a negative of 1, this negative is going to affect the sign that we are having here, and we are now going to have a positive sign, because negative multiplied by a negative is going to be the positive, the one that we are having here. At this point now, we can separate the real functions and the imaginary function. By separation of the real function and the imaginary function, we say that the imaginary function contains the term of j. The real functions do not have a term of j in it. To mean that the Laplace transform of our function f of t is going to be equals to I into s, we subtract from 4, all over s, we add to, s, we subtract from 4, everything squared, we add to 25. We come and add to 5j all over s, we subtract from 4, everything squared, we come and add to 25. From this point now, we have separated the real function and the imaginary function. Since my board is too small, that is why I'm going to write and rub so that I can continue with my working. At this point now, we've separated our real functions and the imaginary function. When we check here, we have our I. The I, we say that it stood in for the imaginary function, and that is the reason as to why we were continuously working with our I. This is the real side, this is the imaginary side. Hence we can come and say the Laplace transform of our function f of t is going to be equals to I stand for the imaginary side. Hence, we are going to cancel out the real side and have our answer as the imaginary side. To mean that the Laplace transform of now our function f of t is going to be equals to 5 all over s, we subtract from 4, everything squared, we come and add to 25. J only stood in for the imaginary side. And this is how you go about finding the Laplace transform of an exponential 4t sine 5t using the first principle formula. Thank you for your time.